I am Radik Raja. My topic is the design of architecture for Territorial Tsunami. My external guide is Dr. K. Satish Kumar from SDRC, and internal guide is Dr. D. Shivakumar. Main scope of our project is to minimize the damages in the tsunami damage in the building due to the tsunami. Due to the tsunami, the buildings get damaged heavier, so it can be reduced by some of the recommendations which have been given. So after the tsunami of 2004 in India, some of the recommendation code have been drafted. So using that recommendation, we have some of the suggestions we have given, and force have been calculated. And using that force, the building structures response have been calculated. And using that response, we have been reducing the damages by implementing some of the recommendations. And tsunami mechanism of tsunami. The tsunami's mechanism is a 4 steps: initiation, split, amplification, and run-up. Initiation is that when a little shake-up which is occurred below the water surface, due to that shake, some of the energy is get generated below the water surface. That generated energy is get evolved from the ground to the surface of the water, and that energy is get traveled. That is the kinetic energy. That kinetic energy is converted into potential energy, and this energy is dragged towards the water surface of the water, and this dragging of energy makes up into the wave, and each wave gets overlapped, and the overlapping wave results in the tsunami. And these are the forces which have been occurred due to the tsunami. First one is the hydrostatic force, buoyant force, hydrodynamic force, surge impingement, impact force, and breaking wave force. The hydrostatic force is that this force acting at the base, all direction of the building, towards all the direction. And the buoyant force is that this force acting at the base, at the bottom slab of the building, which is acting towards the upward direction. And the hydrodynamic force is that this force acting on the building along the seaward direction. And the surge impingement is that sudden impact force, and the impact force is that due to the debris impact, the building get damaged, and the breaking wave force is also the same as that. And these are some of the IS guidelines which have been given. The plan of the building should be a rectangle and square. Other than this, the most preferable is that rectangle. And here, the pattern of the building structures should be a zigzag, so that the pressure can be break out, and the pressure wavelength can be get reduced, so that the damage can be minimized. And here, the face of the building should not be get longer. It should be broken. Shorter direction should be faced along the seaward direction. And this is the we have taken design building, a 9-story building. This is a top view, and this is a elevation view. And we have calculated the reinforcement details and load details for column, beam, slab, and shear wall. And these are the seismic wave calculation of the building for the each floor of the design building. And this is the floor distribution of the lateral force. These lateral force are applied to the building. And this is the tsunami force calculation. According to the guidelines, we have been standard recommendation we have been taken out. We have taken a high tsunami hazard zone, and inundation depth is at 9 meter, and storm surge height is 3.5 meter, and other is the constant values. And these are the force calculations. For each force we have been calculated using this formula. And these are the force combinations, load combinations we have been given to the design building. And these building is a 9-story building which is a rendering view. This is with shear wall, and this is without shear wall. Here the shear wall is placed along the seaward direction, so, and the basement of the floor is kept vacant, so that the water can be flowed free flow. So as the water gets a free flow, the pressure of the water gets reduced, and the damages get reduced. Each load is applied to the building, and for each load the response of the building has been given for with the shear wall and without shear wall. And so live load, hydrostatic, dynamic force, surge impingement, impact force, and buoyant force. And these are the load combinations. And this is the nodal displacement value for with shear wall, and this is for without shear wall. In comparing to this, the with shear wall, the displacement of building in with shear wall is get reduced to 54% comparing to the without shear wall. And this is the displacement graph. And here we have taken an existing building in Nagapatnam. From that, in that existing building, we have been applied the force, so that what are the response which have been applied, what are the response have been arrived for that type of building we have been calculated. And these are the seismic wave calculation, lateral force, and for that building. This is the force calculation for the existing building, and these are the response of the building for that forces. Hereby, the conclusion is that here in the 9-story building we have provided the shear wall so that the huge force have been taken by the shear wall and other force have been distributed to other beam and column. And here the shear wall have been not provided in that existing building, so it can be the damage can be minimized by implementing the shear wall on it. And the face of the existing building is so longer, so along the seaward direction the face of the building should be shorter, so that the damage so that the tilting of the building can be minimized. And here the openings at the ground floor should be avoided. Openings at the ground floor should be placed so that the broken particles like wood, glass, using that material, the construction should be made at the ground floor so that the damages can be avoided. Thank you.